All right, this is chapter 8, number 53. It says draw the best Lewis structure for the nitrite ion, NO2. So NO2 minus 1 charge, nitrogen 5 valence electrons, oxygen 6 valence electrons, times 2 plus 1 extra for the negative charge right here. I got that because nitrogen is in group 15, oxygen is in group 16. 12 plus 5 is 17 plus 1 is 18 valence electrons. Alright, so then we have to take the least electronegative atom, put it in the middle, we'll bond the oxygens around it. So now we have 2 electrons gone, 4 electrons gone, minus 4, that means we've got 14 electrons remaining. So if I want 2, 4, 6, 8, 10, 12, 14, 16, I wouldn't have enough, so I'm going to have to use a double bond somewhere. So let's try a double bond right here. Minus 2, that gives me 12 electrons remaining. 2, 4, 6, 8, 10. 12 electrons remaining, uses them up, put it in brackets like this, and we'd have a minus 1 charge. Now you can also notice you could have put the double bond over here, and so this is what's called a resonance species, and so you have to write it both ways. And so this side then would have the single bond, and then this side would have the double bond, and then you put the 2 electrons over here, the 2 electrons here, 6 around here, negative 1 over here, resonating double bond. And so technically this isn't a double bond and this isn't a single bond, it's like a bond and a half because this bond resonates between the two, and it's like 1.5 bonds, but you can't draw a half bond, so you got to draw both of those types of structures. Letter B, with what allotrope of oxygen is it isoelectronic? So the word isoelectronic means same number of electrons. And so it's asking for an allotrope of oxygen, and so there are several different types of oxygen in the world. There's oxygen, O, there's O2, diatomic oxygen, there's O3, which is triatomic oxygen, also known as ozone. And so we want to have one that has a total of 18 valence electrons, and since oxygen is in group 16, and it has 6 valence electrons, it wouldn't be this one because that only has 6. This would have 12 valence electrons, this one would have 18, and whoa, look at that, we have an isoelectronic structure. O3, ozone, is isoelectronic with NO2 minus. What would you predict for the lengths of the bonds in NO2 relative to the NO single bond and double bonds? So we already talked about this, that these wouldn't be a double bond here and a single bond here. It would actually be like a bond and a half, and so it would be single bond would be like this. A double bond would probably be maybe about this distance, and so the bond and a half would probably be about this. And so strength and length wise, we'd say that the double bond would be the shortest, and it would also be the strongest. And then the bond and a half would be somewhere in the middle here, where it would be a little bit shorter, medium strong. And then the single bond right here, that would be the longest, and it would be the weakest of the three. So it would be kind of in the middle of those. So that's how you could compare the length and strength of those.